We have a problem. One of my friends have designed a super sweet adaptive backpack that can transport whole humans out hiking. His name is LJ, and he built this one-wheeled tandem hiking machine for his daughter. They call it the Huckleberry Hiker. If you notice, it's a rather ingenious invention that transfers most of a passenger's weight to a back wheel, making it much easier to get out hiking and explore the outdoors with someone who might not be able to hike on their own. And the outdoors is for everyone. LJ started selling these on his own last year. The problem is he can't make these machines fast enough to keep up with his orders. So if you don't mind, I have offered him the services of our wheelchair factory, and we now need to ship 100 of these Huckleberry hiking frames by the end of the month. Luckily, we have my cobot friend back here to help out. We're calling him Sparky. We also need some lasers. For the past few years, thanks to you and your views on this YouTube channel, we've been able to build out a massive factory specifically for manufacturing accessible adaptive equipment, like off-road wheelchairs and active wheelchairs. To manufacture a Huckleberry Hiker, we start at the far end of the factory with several long sticks of steel tube. The tube gets slid into the chuck of our Laguna 4,000 watt laser. Yeah, there are cheaper ways of cutting metal, but lasers allow for faster and more precise and more advanced manufacturing techniques, like kirigami, which is a manufacturing technique that allows us to cut away portions of a metal tube so it naturally bends into the exact shape we need, without a lot of extra complicated processes. But I'm getting ahead of myself. The Huckleberry Hiker has a backpack of sorts that the driver or Sherpa wears. And as we shape the metal portion of the tube for that backpack attachment, sometimes it's just fun to watch lasers do their thing. The Sherpa is the person controlling the tandem hiking cart and has the backpack strapped to their body. That particular piece of metal is bent with our CNC bender that we use for the frames of our own Paradox wheelchairs that we also build here at the factory. Even though the laser and the bender do a lot of the initial heavy lifting, we still have to attach all these different sections of metal together by welding. And before we can bring Sparky into the picture, I've got to explain some things. See, Sparky is a cobot, meaning he is a robot that is meant to cooperate with humans in a shared workspace. And I mean no disrespect to Sparky, but he's not smart enough to figure out things on his own just yet. Which means that a lot of the prep work needs to be done by hand. We're using a type of welding called TIG welding, which uses electricity and a pointy tungsten electrode to liquefy different pieces of metal together. This can happen just with the pure heat alone. The tungsten is able to create an electrical arc that is hotter than the surface of the sun, fusing and melting metal together in seconds. A long filler rod can also be added into the mix to liquefy into metal droplets, which add structure to the weld. TIG welding is just as much of an art as it is a science, but the welds that come out of the process are super clean. TIG welding is where we add the small details, like where the wheel connects and the axle tubes that help the Huckleberry Hiker fold in half to make it more portable. We can also tap some holes for screws and attach something called weld nuts. These nuts are specifically designed to be welded to an object, so something else can screw into it. Kinda nifty. Once all the little odds and ends are added to the frame, we can take the individual sections over to Sparky. We got this Sparky from a company called High Robotics. He is a UR-20 and a super hard worker, but as a cobot, he can only do what he is told. He's not going to start learning things on his own or anything, which is, in my book, a good thing. Since we have to build 100 of these frames, Sparky is really good at repeatability, but only if the pieces he's working on doesn't move. If the pieces move even a small millimeter out of alignment, he's going to miss his mark. We could just use standard welding table clamps, right? But since this is a process that needs quick repeatability, we designed custom clamps in SolidWorks. Being able to design and digitally manufacture stuff in a computer first saves about $1 trillion. And it's an industry that we need a whole lot more people dabbling in. SolidWorks does have a deal right now. It's $48 for an entire year. That $48 gets you a non-commercial license for both CAD and CAM, which is software for programming machining. I'll leave a link for them down in the description if you want to level up your employable skill level. There's a massive shortage of good engineers in the USA right now, and we need everyone we can get. And huge thanks to SolidWorks for supporting this project. After the fixtures we designed are bolted to Sparky's welding table, we can tell him where the pieces are located. Getting a computer program to participate in the real world with us might seem difficult at first, but there's actually only 2 buttons on the robot that we use to both move it and program where we want the welds to be in reality. The 2 buttons are located on the head of the robot right next to the welding nozzle. The top button, once pressed, puts the robot into free drive, where I can move it around the table using all 69 inches of its reach. I'll set the robot exactly where I want at the start of the weld and press the second button, which sets a waypoint. Then I can manipulate the robot to the second position, press that second button, which creates another waypoint in the software, and the robot will move between those 2 points in a straight line. So I do have to keep in mind where my clamps are to make sure that the robot won't collide with anything during its path. For the lower piece on the Huckleberry Hiker, we have 2 straight welds that are next to each other, and then we need the robot to lift up, move away, and do 2 more straight welds on the other side. So we do something called an air move, which is a different type of waypoint, so it's not trying to weld through the air as it makes its way around to the other side of the part. The robot, however, is smart enough to know if it does collide with something, so whether it's a human, a fixture, or a clamp, if it does collide with something, it'll stop, pause, and nothing will get damaged. Fingers crossed. We have the UR20 attached to a welding table at the moment, but I have seen people attach the robot to the ceiling and weld from upside down, because in the robot world, you're not as constrained by things like gravity. However, Sparky here is only IP65, so underwater welding is out of the question. During teaching mode, there's a special closed tip that we put on the nozzle. The teach tip helps set the exact distance that the welding gun will be from the part so that the current flows optimally. Once the program is made, we replace the teaching tip with a contact tip and we can start welding like normal. Remember, I only have to teach Sparky where to weld 1 time, and then he should be good to go for the next 100 or 1,000 pieces all on his own. The perk of having a robot is repeatability. The weld settings and air moves will appear on the mobile app or on the included tablet with HiRobotics custom beacon software, which is pretty cool. The UR20 combined with our Miller welder is able to weld both aluminum and steel. Using a wire-fed process called MIG, we first install about a mile-long roll of wire to the backside, which gets fed up into the gun and is what makes the electrical connection so the parts get welded together. You could say it's gluing everything with an arc and some sparks, hence the name Sparky. The robot arm itself can lift about 50 pounds and move at 11 miles per hour. We use some anti-spatter spray to help reduce the spatter, and we'll dial in some more of the settings as we go along. But for now, he's doing a pretty good job. Our parts are kind of small compared to what he is capable of, but we do have some larger projects in the pipeline that we need him for. Hit that subscribe button to keep up with the latest on our factory. We've got some cool things coming. The specially designed cuts that our laser made earlier help notch together the different parts, so there's less room for error. We want these Huckleberry Hikers to be safe and sturdy. Once the parts have finished getting welded, we take them to our steel-encased blast room, where we bombard the parts with tiny glass beads. This makes a more uniform finish on the metal and gets rid of any oils, prepping the frame for powder coating. Bead blasting is the same process used for the texture on the outside of Apple's MacBooks. Powder coating is another awesome process. It's where this colored dust is vacuumed out of a bag and statically adhered to the metal frames, with, again, more electrical current. We use electricity for a lot of things around here. The same static charge that makes your hair stand up, not that I would know, is the same static charge that keeps the powder attached to the metal frame before it goes into the large oven. We bake it for about 20 minutes or so at 400 degrees, like your grandma does with her cookies. And now we wait for about 30 minutes while the powder coating cooks. Oh, good. It's purple. And then it's time for final assembly. This is where the accessory pieces are added to the frame we built. like the seat mount and the branding and the guards and the brass bushings for pivot points. And most importantly, the brake lines, since the hiking sticks cleverly have a brake mounted to the handle that help reduce momentum when going downhill, making it easier for the Sherpa to control the cart. These same hiking sticks are able to click in and turn the hiker into a tripod, with the rear wheel to help loading and unloading the passenger. LJ and his team at Huckleberry Hiking have done a fantastic job with his design, and it's been a blast for my team here at Not a Wheelchair to assist with the manufacturing. LJ's been kind enough to give a $50 discount on his Huckleberry Hiker for anyone who watches this video. I'll put a link down in the description. Helping people get out and explore is what we're all about, and hopefully we'll see even more of these Huckleberry Hikers out on the trails in the future. If you've designed an accessible product and need it manufactured, there's a good chance that my team and Sparky can make it cheaper here in the USA. Or just get a UR20 from High Robotics for yourself. Either way, the link is in the description, and thanks a ton for watching. I'll see you around.